All right, so big topic of the day is division. If I can get my whiteboard to work. Come on. There you go. All right, division of whole numbers. And I don't know if you've noticed the theme in chapter 3, but each section is pretty similar in that they talk about like, what does the operation mean? What does it mean to add or subtract or multiply or divide? And then how do we get it done? So we'll be looking at models for division. And then the models will take us into algorithms. Properties of division aren't all that exciting, but we'll talk a little bit about properties. And that's about it. And then following that, we'll get into exponents and order of operations. As far as models go, models are physical definitions for the operation. And algorithms are sets of rules or processes to get the job done. And then properties are common patterns, often stated as equations. And we've looked at models, algorithms, and properties for addition, subtraction, and multiplication so far. So let's see, common patterns. And so this is the main focus for today. So what we need to do is figure out some models for division so we can explain why we get a certain answer. So think about this division, for example. Suppose we had 12 divided by 4. Okay. So the question is, what is the answer and why does that have to be the answer? So I know you all know what the answer to that is, but if you could think for a minute about a reason that has to be the answer. And there's a bunch of different ways to answer this question. So I'd just like you to make a note about why you think 12 divided by 4 equals, on a good day, I think we mostly agree it's 3. Why though? Why does it have to be 3? So take a moment to write something down on paper. And then after you've written it down and looked at it, if you would like to share, please feel free to voice in or jump into the chat and let us know what you think. Okay, we got a chat. Let's see what we got. 4 goes into 12 3 times. It takes 3 4s to get 12. 12 things distributed equally into 4 groups. Ooh, we've got 3 different answers, I think. All right, so new page. Let's play with these. So again, we're looking at 12 divided by 4 equals 3. And reasons, 4 goes into 12 3 times is 1. And then another one is it takes 3 4s to get 12. And then another one 12 things. And I just putting the question marks in front because I want to like break them down, make sure we all agree on this. 12 things distributed equally into 4 groups. All right. Okay, so 4 goes into, what do we mean by goes into? Goes into 12. So I have 12 things. Let's make 12 things. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 things. Maybe they're cherries. And 4 goes into 12. Goes into. Anybody want to help me out on what goes into tells me to do here? Goes into. I've heard the phrase, I can use it in a sentence, but I'm not sure what to do with it physically. I guess that's another way to read this. 4 goes into 12 3 times. Okay. So this seems like a rewriting of it, but I'm still not sure why, because I don't know what goes into means, besides it's another way to state divide. Okay, so we'll come back to that. It takes 3 4s. Okay, so here's a 4. Here's another 4. And here's another 4. Okay. Yeah, so this one here is telling me to look for 4s, I think. Unless I'm misinterpreting anyone. Oh, and then Avali sent me a response. Conjoin. Oh, so were you giving me an alternative to goes into there? Which maybe is what I'm doing here. I'm joining together 4 things. Okay, I think I buy that. So this could mean the same thing I just did with the statement below. All right, and then 12 things distributed equally into 4 groups. Okay, well here I have 3 groups, so that's different, huh? Let me think about this one down here, because that seems different than what's going on above. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'll be a little neater this time. And then I want to distribute the 12 things into 4 groups, okay? Oh, my columns kind of coincidentally made 4 groups, right? If I split them up into columns, I now have 4 groups of 3. Oh. Whereas this one up above is a slightly different approach, right? That is, come on, pen. This one right here is 3 groups of 4. Different picture, same total. 3 groups of 4. Okay. So unless somebody is thinking something different than me, I think these two are kind of saying the same thing. We just have to reinterpret what goes into means. And although I use that language a lot, it doesn't mean much more to me than divide. What does divide mean? Does divide mean this? Does divide mean that? Do they give the same answer? So I think I'm gonna then say here is one interpretation or model for what 12 divided by 4 means, model. And this down here is a second model for what division means. And then, all right, so nobody else shared. Does anybody have anything else to share about why 12 divided by 4 is 3? Same, okay. All right, so at least one person wrote the same thing as another here. All right, so let's see. Yeah, let's pick on this first one here. And I'm going to give it a name. So again, we're looking at models for whole number division. And model number one, now I call it the groups in model. And if I have something like 12 divided by 4 equals what, the question this model asks is how many groups of 4 are in 12? So if somebody says, well, what does division mean? I would say, well, division means groups in. So if you see something like 12 divided by 4, it means how many groups of the second number are in the first number. So how many groups of 4 are in 12? And we can grab some toys or fingers or cherries or whatever and figure that out, okay? So we're looking for groups of 12 in 4. There's one group of 4, two groups of 4, 3. And so we can draw that and then say, oh, there are 3 groups of 12. Oops, sorry, 3 groups of 4, excuse me, in 12. So that means 12 divided by 4 equals 3. A related version of this, maybe I'll call this model 1B, is the idea of repeated subtraction. Some people view it as the same as groups in, some people view it as different. I kind of view it as different. Our book has it kind of lumped in as the same model as that. So the question here would be, how many times can I subtract 4? From 12. And there's kind of a little catch to get close to 0. Zoom is in the way to get as close to 0 as possible. And some people think that second part after the comma is implied, but you got to be careful about what you imply. So start with 12 and take away 4, that gives me 8. And then 8 take away 4, that gives me 4. And 4 take away 4 gives me 0. I can't get much closer than that. And so I get that this happened 3 times. So I subtracted 3 times, so 12 divided by 4 must be 3. And that's kind of like finding a group. So here's one group of 4 here. So this one right there matches that one right there, and so on. This group right here is that subtraction there, and this group right here is that last subtraction there. We've accounted for everything. The answer is 3. So again, I think they're 2 different models. Our book kind of lumps them together as the same. So the book calls this the subtractive model for subtraction. If we compare that to the other that we saw on the previous page, this is going to be model number 2 officially. This is called sometimes the set partition model for subtraction. Or for division, excuse me. And let's use the 12 divided by 4 again as our example, and we'll try some other numbers in a minute. So in this case, we want to split or divide 12 into 4 equal groups. How many will be in each group? So we have 12 things. We make our 4 groups first, and then we start putting stuff in there. So usually I just go through and count. 1, 2, 3, 4, keep going, 5, 6, 7, 8, keep going, 9, 10, 11, 12. I just ran out. There are 3 in each group. So 12 divided by 4 is 3. And that's a different picture, right? Here I have 4 groups of 3. In the groups in or subtractive model, there are 3 groups of 4. Right? Different organization, different physical model. They are not the same, even though they help us get the same answer. Names of some things here, just to make sure we're clear on that. The result of division is called a quotient. The number we start with out there is our dividend. And that second number there is our divisor. So we have a dividend, a divisor, and a quotient. Sometimes we get a remainder. We'll get to that in a moment. All right, so we've got 2 very different models, possibly 3 so far. Here is another one. We'll call this model 3, the missing factor model. $12 divided by 4 equals what? If you read it backwards as multiplication, it says what times 4 is equal to 12. And if we know multiplication, we should be able to guess at the result. So in multiplication, the number I'm looking for is called a factor. That's why this is called the missing factor model. So factor times factor equals product. That missing factor turns out to be my quotient. And let's see, yeah, I remember 3 times 4 is 12, so 12 divided by 4 must be 3. And so we can look at it as multiplication to get the answer. And those are the main physical models of what subtraction means. Now, I think I like the first 2 models better because they're more physical, right? I can take a set of objects and play with them and come up with an answer. Whereas this third one's a bit more abstract. I have to think about a multiplication problem, which may prompt me to play with some toys. In which case I would either use the first or second method to come up with this 3 here. So we have a couple of different ways, few different ways to think about what does division mean? Why do I get a certain answer? And again, this third one is more of a definition based on multiplication that they work together. Speaking of which, this leads to kind of a more general definition called the division algorithm. Which doesn't exactly tell you how to do division, but it tells you what the result of a division ought to look like. So the division algorithm looks something like this. If you have, let's say, these numbers n divided by m, that's going to result in these 2 other numbers, q and r, where n equals q times m plus R. And breaking this down a little bit more, some conditions, R has to be greater than or equal to 0, but less than M. Okay, so R is my remainder. Q is my quotient. So every division problem leads to a quotient and a remainder. Now the remainder could be 0, but it has to be less than the divisor, right? M is my divisor. I'm looking for groups of size M. And if there's a group bigger than size M, I can make a group size M. Once I have less than M, I can't make any more groups of M. So we'll just apply this to a different example. This right here is what's known as the division algorithm. That if you divide two numbers, you get a result that's two other numbers, and the connection between them is this multiplication problem right there. That's how they're related. Alternative version of what's in the box there, by the way, which isn't often cited, but if I go back to my original n divided by m, then that's going to be equal to that quotient plus the remainder over the divisor. And we could put that in fraction form also. And then the screen is going to get a little bit too busy. So if we write our division in fraction form, oops, there should be an M there. But typically it's written as it is in the yellow box here. All right, so we're going to try that. So again, we're trying to define n divided by m. And the division algorithm says you can find these other numbers q and r, where n is equal to q times m plus r. And so our goal here is to figure out for a given n and m, what does q and r have to be? And remember, r could be 0, but it's got to be less than the divisor, m. So let's take, how about 18 divided by 5. So according to this, 18 is my n. We should be able to rewrite 18 as some number times 5 plus some other number. Now, there's lots of ways that can happen. So, oops, that's supposed to be a 5 there. This part of 5. There we go. So for sure, I could say, well, I could just take 1 5, which would leave me 13, but that doesn't work because 13 is too big. Okay, so I could try 2 5s. That would be 10, so I would have 8. Nope, still too big. 18 could be 3 5s. That would be 15, which leaves me 3. Oh, that's less than 5. Which means we are done. We have found our quotient and our remainder. And sometimes that would be written, especially with younger kids, that 18 divided by 5 would be equal to 3, remainder 3. And they often use a big R for a remainder. So you've probably seen that notation before. For older kids, we often write it different. We might say that 18 divided by 5 is equal to 3 and 3/5. 3 out of 5, right? Because we were taking this out of 5. So this is an alternate for older kids. This is the younger kid version. And so what I was trying to do right here is use it as a process where I can kind of guess at the quotient and figure out the remainder. Guess at the quotient, figure out the remainder. Guess at the quotient, figure out the remainder until I get that part right. And so that's the algorithm part of this idea right here. So we can take it systematically. Some kids take a lot of random guesses. I remember doing that when I was a kid. So we're going to take a look at that next. So what we have so far is the idea of what does it physically mean to be division, and our first stab at a division algorithm. And so we're going to play more with algorithms next.